Okay, this is the video lecture for Honors Math 3, Unit 9, Objective 7, Double Angle Laws. So normally we would actually take a look at the sine, cosine, and tangent double angle formulas, but due to the circumstances, we will only be reviewing the double angle law for sine. So this is the only one we will be doing. So the way we're going to use it, so you can use it both ways. You can use it as an expansion, or you can use it as a combining or contraction. So the way we are going to be using it is this way. So if we have 2 sine theta cosine theta, that is equal to sine of 2 theta. So this is the way we're really going to be using it here. So that is what all of our practice will be on, is this version right here. So the first thing I want to do, though, is this part right here, where it asks us to verify it using the angle addition laws, because this is also a good review for us for that. So just a reminder, so this is from one of the earlier objectives prior to the school closure. So we had sine of alpha plus beta, and so that expansion or identity was the same as sine of alpha, cosine of beta, and then plus cosine of alpha, sine of beta. So that was from objective 4. So we had that in objective 4, that identity there. So that was just our way to expand the sine of alpha plus beta. So when we're adding 2 angles, we can write it like that. So this one is asking us to verify that this is the same. So we know that if we had sine of 2 theta, we could rewrite that as sine of theta plus theta, right? So if I had 2 theta, that's the same as theta plus theta. So I'm going to go ahead and expand it using the identity from objective 4. So instead of alpha and beta, I'm going to have theta and theta. So then again, so I'm going to use theta, the thetas, right? Because that combines to 2 theta, and I'm just trying to verify or show that this is true. So if I replace alpha with theta, and also replace beta with theta, and do the same over here. So I'll have cosine of theta, oops, and then sine of theta. So all I did was do that substitution. And so if I look here, even though the cosine and sine are reversed in their position, because multiplication is commutative, then these really are the same, right? So then I really have sine theta, cosine theta, and then I can reverse that product to be sine theta, cosine theta. And so I have 2 things that I'm adding together, so that is the same as 2 sine theta, cosine theta. So all I'm doing is kind of verifying that identity. So this identity, a lot of times students get a little bit confused about, because when we simplify, they always are asking that question, well, where did the cosine go? Like, what happened to it? Where did it go? So again, we are trying to simplify, we're trying to use this identity. So there's an identity out there that is saying that if I have a product of sine and cosine, right, if I have a product of sine and cosine, that I can rewrite that to sine of twice the angle. So it's not like the cosine is disappearing, it's just that this combination of things turns into this right here. And that is because of this identity above, okay? So the cosine doesn't go anywhere. It's just the combination of the product of a sine and cosine with the same angle, if it has that coefficient of 2, that is equal to that identity there. So very similarly, like with the thought of, well, if I had sine squared plus cosine squared, I know that I can rewrite that entire thing, I can rewrite it as just a 1, right? Because they are equal to each other, right? That's some sort of identity. We also have that same identity with like tangents and cotangents and that sort of thing. So if I had 1 plus tangent squared, I know that both of these together, when I see both of them, I can rewrite that as secant squared, right? So I know that I can do a lot of flip-flopping and interchanging of numbers and trig functions and rewrite them to where they look totally different. And that's the same exact thing that I'm going to do here. So this is the one I'm looking at. Okay, but again, just as a reminder, the way I want to view it, so I'm going to write that right here up, is I want to really look at it in this form, because that's the form I'm going to be using. Okay, so all I'm doing is just writing it. So this is the one I really want to make sure I understand. So if I have the product of sine and cosine with the same angle, then with a coefficient of 2, I can rewrite it, so I can completely like just get rid of it and rewrite it to sine of double the angle, okay? So it's not like the cosine divides away or subtracts off of it or anything like that. It's just an identity, just like I can take sine squared plus cosine squared, get rid of both of those terms, and just replace it with a 1, okay? So if I see the product of sine and cosine, I can get rid of all of that and replace it with sine of double the angle, okay? All right, so how do I recognize that that's what I want to do? So for question number 1, I have a product of sine and cosine, but I don't have that coefficient of 2, so I want to go ahead and fix that, right? Because I want it to look as much like this as possible. So instead of the 12, I want it to be a 2, so I'm going to rewrite that as 6 times 2, because 6 times 2 is 12. And then sine and cosine, because it's multiplication, I can rewrite it. So I'm just going to kind of scramble up the problem. So I'm just scrambling the problem up. So what did I do? I broke up 12 to be 6 times 2 because I need to have that 2 there. And I want sine and cosine to be in the right order. I don't have to do that step, it just kind of makes it look a little nicer. So then again, I know that if I have a product of sine and cosine with matching angles and a coefficient of 2, I can replace all of that, right? So all of that's going to go away and be replaced with sine of 2 theta. So all of this right here is going to be equal to sine of 2 theta according to that identity. And then I know in particular what is theta. So theta for this particular problem is 2 pi over 5. Okay, so I still have that 6, right? So that 6 is going to come right down to be 6. And then I'm going to use the identity. So all of this is going to replace with sine of 2 times theta. And so then that is just equal to 6 sine of 4 pi over 5. Okay. Okay. So let's do another one. So let's take a look at question number 2. So for question number 2, so same idea. So I have a product of sine and cosine with matching angles. So I need that 4, I want it to match, to be like that too, right? Because I'm looking to make it mirror or mimic this identity side over here to convert it to this identity here. So I know 4 is the same as 2 times 2, and then the sine 40 cosine of 40. So this is the identity, right? So if I have a product times 2, I can replace it with sine of 2 theta. And for this particular problem, theta is 40 degrees. Okay. So that 2 is going to come down, right? So that 2 is still there. That doesn't go away. And then all of this, right, all of this is going to replace with sine of 2 theta. So that's just an identity, just like we have been using up to now. So then this will be sine of 2 times 40 degrees, because theta is 40, which is the same as sine of 80 degrees. Okay. All right, so let's take a look at question number 3. So again, I want this to be a 2 in front here, right? So I'm going to rewrite 6 as 3 times 2, and then I still have sine and cosine. Oops, forgot my 4x. So sine and cosine. So this is the identity part, right? Because I have the product of sine and cosine times 2. So that 3 is going to stay there. And then this is going to turn into sine of 2 times 4x, which is just an 8x. Okay. So the cosine isn't like disappearing, right? So like you can't think of it as like, oh, the cosine just magically disappeared. We're doing a substitution. Just like when we see a 1, we would replace it with sine squared plus cosine squared, or vice versa. If we saw sine squared plus cosine squared, we'd kick out both of those terms and replace it with a 1. If we saw 1 and tangent squared together, we know to swap that out for secant squared. So it's kind of that same idea that if I see a product of sine and cosine times 2, then that right there, all of that can be replaced with sine of just double the angle, okay? So here I see I have a 2, I have a product of sine and cosine with that same angle. So then all of that is going to turn into sine of 8x. Okay. All right. And then I want to do just a few more here, so just a couple of extras. So we're going to take a look at number 1. So this one's a little tricky because I don't really have a coefficient other than a 1 there, right? And so but I still need to have that kind of 2 times something factor, right? So I know that I need that 2 there, right? Like I have to have a 2. But I know the final product has to be a 1, so then this isn't going to end, so this will end up being 1/2 times 2. So 1/2 times 2 will give me that 1. So if I multiply by 2, I also need to divide by 2, right? Just to get back to 1. And so then now I have 1/2, so 1/2 is that coefficient, and then sine of double the angle. So 2 times 3y, so that would be 6y. Okay, so again, right, what am I doing here? I'm doing 2 sine theta, cosine theta, right? So the product of sine and cosine, as long as there's a 2 there, is going to be equal to sine times double the angle, right? So that's what I'm using, is that new identity. All right, and then let's take a look at 2 more here. So this one here. So again, I have that whole like 5, right? So I can't have a 5. I need to have 2 times something. So 2 times something. So I know that that could be just 2.5, right? So half of 5 is 2, or excuse me, half of 5 is 5/2. So I would just have half of 5 is 5/2. So all I did was rewrite 5 to be 2 times something, right? So I'm going to do 2 times 5/2, or 2.5, that would be fine as well, or 2.5. So, and so again, the product of that, so the 2's would cancel, would just give me 5, which is what I started with. And then this right here is my identity, so a product of sine and cosine that is being doubled. So then the 5/2 just comes down, and then all of this gets replaced with sine of double the angle, so instead of 25, 50 degrees. And one more here, so this is a review on an old one, so just to kind of show you that. So I don't have that product of sine and cosine, and I certainly couldn't make this a product of sine and cosine, but what I should be able to do is recognize that I have a coefficient of 4, so I could factor out that 4. And I know that addition is commutative, so it doesn't matter if I write it that way or if I write it with the sine term first, right? Those are equal statements. And then now I have this identity, so I know this one pretty darn well, right? This is that Pythagorean identity. So I know that if I have sine squared plus cosine squared, that is just equal to 1. So I'm going to replace both of those terms with 1. So 4 times 1 would be 4. And that is the end of that.